Hello. Mic check. Mic check. 1, 2, 3. All right. Mic check. Mic check. 1, 2, 3. All right. So welcome everyone to Malaysia Online Tuition live session. Okay. So for today, we are going to be discussing on Pure Maths 1 and Statistics 1. Okay. For the upcoming exam next week. Okay. So for today, what we are going to be discussing about, okay, will be on past papers, of course. Okay, and as you can see on your screen right now, the first question that we are going to be discussing is going to be from summer 2023, paper 13, question number 3. Okay, so for today, we are going to be discussing only like medium, high to high difficulty questions. Okay, all right. So for the first question from Pure Maths 1, so this will be about expansion, okay, binomial expansion. So first thing first, they ask us for the complete expansion of the given bracket, okay, binomial expansion. So we can first write the function inside the bracket and then to the power of 5. So this one is just a matter of applying the formula provided. Okay, it is provided, by the way, provided in our uh, formula sheet. Okay, so let me show you where that formula is. Let's go up. Yeah, this one, as you can see. This is the one, binomial series. So this is the one that you are going to be applying. Okay, so after you apply this, then it's done. Okay, so let's do that one by one. Okay, so you can see a to the power of n. Okay, and then just apply this one to one. Okay, one to one meaning you just take whatever that is a and then whatever that is b, and then you just follow everything lah. Okay, so now let's apply that. So first, our A is this one. Okay, our A is this one, our B is this one. And then we can first write x to the power of 5. Okay, and they didn't mention anything about whether ascending or descending order. So don't worry about that. Okay, so as long as you get the complete expansion, it's fine. So, okay, thank you. Okay, I can hear you. Okay. You can also comment whether the quality is okay or not. All right. So, yeah, you can just comment anything. Okay, but please comment nicely. Okay, I don't want you to use any bad language lah. Okay, so x to the power of 5 and then plus. Okay, so according to the formula, it is 5, 1. Okay, okay, or you can write 5c1 as well. Okay, 5c1 and then x to the power of 4 because just now your power of x is 5, so now it's 4 lah. And then the 2 over x will be to the power of 1. Okay, it's just the normal binomial. You are applying the same formula for your binomial distribution for stats 1. Okay, and then 5c2 and then x to the power of 3. You can see that the power of x is getting smaller and smaller and the power of 2 over x is getting bigger and bigger. Okay, and then you can just continue this manner until you are done. Okay, so x squared and then 2 over x to the power of 3. Okay, so you know lah what's going to happen next. Okay, and then finally we reach the end, which is to the power of 5. So 5c5, okay, which is just 1. So x here to the power of 0. So whether you want to write it or not, up to you lah. Okay, and then finally 2 over x to the power of 5. Okay, so that's all for the first part. Okay, and then you have to simplify everything. Okay, so then we can write x to the power of 5 plus 5c1 is just 5. And then times 2. Remember, so this is 10. X to the power of 4 divide x is x cubed. Okay, 5c2 is 10. 2 squared is 4. So 10 times 4 is 40. X cubed divide x squared is just x. You can see that the power of x decreases by 2 each time. So 5 and then 3 and then 1 and then next will be negative 1. Okay, so 5c3, if I'm not mistaken, 5c3 is also 10. Let me check. Yeah, 10. So 10 and then 2 cubed is 8. So 10 times 8 is 80. Okay, but this time x squared divide x cubed, that is going to be 80 over x. Like that. Like I said just now, the power 5, 3, 1, and then negative 1, and then negative 3, and then negative 5. Okay, it goes that way. And then 5c4 is 5. So 2 power of 4 is 16. So 16 times 5 is also 80. And then like I said just now, the power will decrease by 2. So just now x power negative 1. This now x power negative 3. And finally, the last one is going to be 2 power of 5. You know x power of 0 is just 1. 5c5 is also 1. So 2 power of 5 is 32. So 32 over x to the power of 5. So this is the complete expansion of the bracket. Okay, that's all. All right. So, okay, the most important part is the next one, which is part B. Okay, this is part A. Okay, so in part B, they give us another bracket. Okay, so we can first write down, okay, bx squared, and then the bracket that we expanded in part A, which was x plus 2 over x to the power of 5. Okay, and what they give us, the information that they give us is coefficient of x is 0. So we can say x to the power of 1 is 0. And then they said 1 over x is 80. Okay. So after you have seen this information that they gave, what you need to do next is for you to understand that we only need the expansion of x power of 1 and the expansion of 1 over x. That's it. Okay. So what we are going to do next is we are going to rewrite, okay, this a plus bx squared. And then for the next bracket, we have to write down everything. Okay. Or there's another way. Okay. A plus bx squared. Now let's look at A first. A must be multiplied with x to get x power of 1. And A must be multiplied with something over x to get 1 over x. Okay. And then for bx squared must be multiplied with 1 over x to get to get x power of 1. And then bx squared must be multiplied with 1 over x cubed to get 1 over x. So the only terms that you need from the previous part, which was part A, only x, 1 over x, and 1 over x cubed. Okay? But if you want to write everything, it's fine. Okay? But these are the things that we need to use from the previous part, which was part A. Okay? So like I said, up to you. Okay, let's say you don't know the blue part. Okay, it's fine. Let's just write everything inside. 40x plus 80 over x plus 80 over x cubed plus 32 over x power of 5. Okay, I'll be using two different colors lah, okay, for x power of 1 and also 1 over x. So like I said, A must be multiplied with x. So that means A with 40x, and bx squared must be multiplied with 80 over x, because x squared divide x is x. Okay, so the red color arrows for x power of 1. And for 1 over x, like I said, constant must be multiplied with 1 over x. So that is 80 over x. And bx squared must be multiplied with 1 over x cubed, because x squared divide x cubed is 1 over x, right? So bx squared with 80 over x cubed. Like that. Okay, so those are the terms that you need from the expansion from part B. Okay, other than that, you don't need to use them. Okay, so now we can write like this. A times 80 over x plus, okay, wait. No. That is for 1 over x. Okay, A times 40x plus bx squared times 80 over x. So this is going to be 0x lah, okay? I'll write 0x because the coefficient of x power of 1 is 0. So that's why I write 0x. And then you can just cancel everything involving the x because we just want to compare the coefficient. So we write 40a plus 80b equals 0. So from here, you can see that 40a equals negative 80b, a equals negative 2b. Okay, so that's from our first part, which is the x power of 1. Now we are going to do for the 1 over x. So as usual, we write a and then 80 over x plus bx squared and then 80 over x cubed equals, okay, remember, like I said, the 80, the coefficient, you just write 80 x, 80 1 over x, okay? I like that. So you can cancel the x, okay, x squared with x cubed, 1 over x, okay? And then you get 80a plus 80b equals 80. So you can divide everything by 80. So we get a plus b equals 1. And since our a is negative 2b, so we can write negative 2b plus b equals 1. Negative b equals 1, b equals negative 1. Which brings our value of a to negative 2 times negative 1, which is 2. Okay, so the values of a and b are 2 and negative 1 respectively. Okay, all right. So that's all for this question. Okay, let's check the answer first. Yep, a is 2, b equals negative 1. Okay, so I hope you understand about this question. Okay, all right. So that's all for the first question for today, which is from summer 2023, question paper 13. Okay, so I'll be doing pure maths 1 first, and later on we will move to S1. Okay, all right. So for our next question, let's see. Okay. Oh yeah, this question. Okay. All right. I think we can discuss this question. Okay. It's from the same year, the same exam. It's just a different variant. Okay. Okay, this one. Question paper 12. Okay. Summer 2023, question paper 12. And then question number 7. Okay. All right. So for this question, where is it? Okay, they said we need to first expand the given bracket, find the 3 solutions of the given equation. Okay, no problem. So first, let's expand what they asked us to expand. Okay, so we are given cos theta plus sine theta squared. Okay, so we need to expand this bracket first. So expanding this, we get cos squared theta, okay, plus 2 sine theta cos theta, and then plus sine squared theta. Okay, remember that cos theta plus sine theta, okay, bracket to the power of 2. If the expansion is this, then they said cos theta plus sine theta, okay, bracket to the power of 2 is equals to 1. Okay, so then we can replace this as 1 squared equals, okay, cos squared plus sine squared, let's bring them together. And you know that this is going to be equal to 1 later. So we write plus 2 sine theta cos theta. Okay. After that, we can replace the 1 squared with 1. And then cos squared plus sine squared is also 1. And then plus 2 sine theta cos theta. Okay, so you can see that 2 sine theta cos theta equals 0. Because you shift the 1 to the left-hand side, so 1 minus 1 is 0 lah. Okay, and then remember, this is very important. They want the range of theta to be between 0 until pi only. Okay, 0 until pi only. All right. So make sure whatever answer, the 3 solutions that we get, it is between 0 until pi inclusive. Okay. All right. So now, let's solve for sine theta equals 0 first. Then cos theta equals 0. So for sine theta equals 0, you know that our sine will be 0 when our theta is 0 and pi. Okay, and how do you know this? You have to go back to the basic, which was the graph of sine and cos. Okay, graph of sine, the basic graph. Okay, the basic graph of sine and the basic graph of cos. So for cos theta to be equal to 0, our theta must be pi over 2. Again, how do we know this? From the basic graph of sine and cos. Okay, so these are the 3 solutions. Okay, so our final answer, theta equals 0, pi over 2, and finally pi. Okay, that's all for the first part. Okay, okay, you're welcome. Okay, I hope this live session helps you. Okay. Oh yeah, for anyone who is watching, okay, maybe after this question, anyone who have like any particular question that you would like to ask, okay, like from Pure Maths 1, okay, we are doing Pure Maths 1 first. please write in the comment lah which question and which question paper lah. Okay. All right. Let's move on to the second part, which is part 2. So they ask to verify the only solutions for the given equation are 0 and half pi. Okay. For this one, okay, for part 2, you can see that they said cos theta plus sin theta equals 1. Okay. So how do we know this? Okay, it's like this. You know just now that the solution that we have is 0 pi over 2 and pi. So the way to verify, you can do like this. When theta equals 0. Okay, so you can write cos 0 plus sine 0. What is this? So you can see cos 0 plus sine 0 is 1 plus 0, and that is going to be equal to 1. So correct. Okay, meaning theta equals 0 is the solution. Okay. Next, when our theta is pi over 2, we do the same thing. Cos pi over 2 plus sine pi over 2. So cos pi over 2 is 0. Sine pi over 2 is 1. Okay, you can use your calculator for this. And again, we get the value of 1. So this is also correct. And finally, we test for theta equals pi. And when we do so, you can see cos pi plus sine pi. We know that sine pi is 0. So cos pi, if you use your calculator, you will get negative 1. So negative 1 plus 0 equals negative 1. So pi is not the solution, as you can see that. So that's how we verify that only 0 and pi over 2 are the solutions, okay, for the equation given. Okay, so that's all for the second part of A. Okay, next we need to prove identity. Okay, so proving identity, quite a nightmare lah, okay, for some of the students. Okay, but don't worry, we'll try together. Okay, so let's write the expression that we have first. Okay, cos theta plus sine theta, and then plus, okay, divided by, okay. And please, whenever you are proving identity, please don't write the right-hand side, okay? Because some of you don't get the answer because you write the right-hand side, okay? Don't do that. Just write down everything on the left-hand side, do it, and then later on, you have to prove that it is equal to the right-hand side. That's what you do, okay? All right. So when we look at this expression, the first thing that we can do is to cross multiply lah. Okay, cross multiply as in rationalizing the denominators lah. Okay, like that. Okay. The first step that you are going to use also depends on the answer. Okay, the answer given at the bottom, they get 1 minus 2 sine squared. Okay, so let's us first check. Okay, what do we get after we do this? Okay, so we have okay, sine theta, and then cos theta minus sine theta. Okay, and then plus, okay, this one you have to expand. 1 minus cos theta, and then cos theta sine theta plus sine theta. Okay. Okay, and then everything divided by, okay, so the bottom, you can see that if you expand this, okay, they are just like conjugate of each other, you will get cos squared minus sine squared. Okay, I'm what we call it shortcut a bit lah. Okay, you can check on your own that the expansion is going to be cos squared minus sine squared later. All right. So now, you can see from the answer, the bottom is going to be 1 minus 2 sine squared. And to achieve that, your cos squared, you have to change to 1 minus sine squared. Okay, so let's expand the top part. Sine theta cos theta, okay, minus sine squared. And then for this one, plus cos theta plus sine theta minus cos squared minus sine theta cos theta. Okay, yeah, it's a bit long, but don't worry. You can see that sine theta cos theta minus sine theta cos theta cancels each other. Okay, and then you have, as you can see, negative sine squared minus cos squared, and that is going to be the 1. Okay, because you know that sine squared plus cos squared equals 1, right? Okay, so we'll do that afterwards. So then the denominator, like I said, you change the cos squared into 1 minus sine squared. Okay, and then minus sine squared. Okay, so 1 minus sine squared minus sine squared, that is going to be minus 2 sine squared later. All right, so on top we have cos theta plus sine theta, and then minus, inside bracket you write sine squared plus cos squared. Like I said, this is the one that is going to be equal to 1 later. over 1 minus 2 sine squared theta. And finally, we have proven the identity cos theta plus sine theta minus 1 over 1 minus 2 sine squared theta. This is how you prove identity. Okay, don't write the right hand side. Prove that the left hand side will be equal to the right hand side. Okay, so that's all for this part, okay, which is part B. And finally, for part C, okay, they asked us to use the results from the previous parts that we have done to solve the equation given, and again, for 0 until pi inclusive. Okay, let's try. Okay, for part C. So the left-hand side has been proven to be cos theta plus sine theta minus 1 divided by 1 minus 2 sine squared theta, and now equals 2 open bracket cos theta plus sine theta minus 1. Okay. All right. So this step is very crucial. Okay. Please listen carefully. This step is very crucial. Most of the students can see here that we can straight away cancel cos theta plus sine theta minus 1. Okay. You can do so, no problem. But, okay, there's a but here. But if you want to cancel this, you have to ask yourself, do you have the solution for what you have cancelled? Okay, what I mean is, do you have the solution for cos theta plus sine theta minus 1? Okay, and if you look back from A part 2, we have the, okay, wait, from A part 2 here, we have cos theta plus sine theta equals 1, which if you shift the 1 to the left-hand side, it becomes cos theta plus sine theta minus 1 equals 0. And we already have the solution to be theta equals 0 and pi over 2. So the question whether you can cancel or not the cos theta plus sine theta minus 1 depends on whether you already have the solution or not. If you already have the solution, which we had, okay, which we have the solution 0 and pi over 2, then yes, you can cancel straight away. Okay, but if you haven't canceled, if you don't have the solution yet, then you have to solve first for what you are going to be canceling. All right, so since we already have the solution, we can cancel altogether. Cos theta plus sine theta minus 1. Okay, now we are left with 1 over 1 minus 2 sine squared theta equals 2. So now we just have to solve for this. So 1 equals 2 minus 4 sine squared theta. So this is going to be 4 sine squared theta equals 1. Okay. And then sine squared theta is 1 over 4. Remember, whenever you have square there, you are shifting the square to the right hand side. Other than the square root that you will have, you must put the plus minus as well. Please remember this, plus minus, okay? Square root 1 over 4. Then we have sine theta to be plus minus 1 over 2. So you have to solve for plus minus 1 over 2, okay? Which means we are going to take all the quadrants, meaning first until fourth quadrant, okay? First until fourth. But since our solutions that we need, okay, is between 0 until pi only, so we are just going to be considering first and second. Because 0 until pi meaning first and second quadrant. Okay, so the rough angle is just sine inverse of half. Okay, and that is going to be pi over 6. Okay, like that. So let me just write all the answers. Okay, because the formula that you need to depend on, okay, if you remember, the first quadrant is theta, and then pi minus theta for the second quadrant, pi plus theta for the third quadrant, and 2 pi minus theta for the fourth quadrant. So for the first quadrant, theta, which means pi over 6. Okay, so we can write the answers. Theta equals 0. Okay, you have to put the solution for the cos theta plus sin theta minus 1. Because if you don't put the 0 and pi over 2, then your answers will be incomplete. Okay, so the first solution is 0, followed by pi over 6. Okay, and then the next is pi over 2, which is from the cos theta plus sin theta minus 1. And finally, the last solution is the second quadrant. So theta, pi minus theta, which is pi minus pi over 6, which is going to be 5 over 6 pi. Okay, let me check. Can't be so confident. So 1 minus 1 over 6, we get, yeah, 5 over 6 pi. Okay, so you need to get 4 answers. Okay, 0, pi over 6, pi over 2, and 5 over 6 pi. All right, so that's all for this question. Let's check the answer first. Yes, 0, 1 over 6 pi, 1 over 2 pi, 5 over 6 pi. Yeah, correct. Okay, so yeah, that's all for this question. Okay, so I would like to ask whether any of our viewers right now who have like any particular question that you would like me to solve. Okay, I'll give some time lah for you to find like any particular question. If not, I will just proceed with my tentative lah, meaning I will be doing like some other hard questions. The formula that you need to depend on, okay, if you remember, the first quadrant is theta and then pi minus theta for the second. Okay, it's okay. Let's just proceed first with the next question. So next one, okay, wait, let me choose. Okay, okay, not interesting enough. Wait, oh yeah, this one. Okay. All right. So some of you may have tried this question before, but okay, maybe you don't know how to do it. Okay, it's fine. Now, the question paper is the same question paper, but different question, which is question number 9. Okay, let's look at this one. All right. So the concern here is not part A. The concern is part B. Okay, but we have to first go through part A first lah. Okay, so for this question, they give us the second term of a GP, okay, and also the sum to infinity. So what we need to do is we first write, okay, second term is 16, and then sum to infinity is 100. So when they give us like this, okay, what you need to do is you change the T2, okay, the second term into the formula of GP, which is AR equals 16. And then for the sum to infinity, you also change it to the formula for sum to infinity. So that is going to be A over 1 minus R equals 100. Okay. Next, we can see that how to make sure that we get the what they want possible values of the first term. Then we need to find for A, which means we make our R as a subject, which means we have R equals 16 over A, and we replace this inside the sum to infinity formula. So A over 1 minus 16 over A equals 100, something like that. This is what you are going to get. And then we can rationalize the denominators, of course. So we have A over A minus 16 divide A, and this A can go up, equals 100. So then we have A squared equals, okay, so we can shift this to the right. A squared equals 100, and then bracket A minus 16. Okay, so we can see that we have a quadratic equation. A squared equals 100A minus 1,600. Then we shift everything to the left. We get A squared and then minus 100A plus 1,600 equals 0. Okay, by using your calculator, okay, or you use your own factorization, okay, you can get the two values of the first term. Okay? A here and A here, 80 and 20 minus. So our A is 80, or it can also be 20. So these are the possible first term, okay, for our GP. So 80 and 20. Okay. So why do we need part A before we move on to part B? Is because for part B, they mention something about the possible geometric progression. So the first possible geometric progression is by using the first term 80. And the next one is by using the first term, 20. Okay. So they said nth term, okay, is equal to the 4 to the power of n minus 2 multiplied by the nth term. Okay, so this is the problem. Okay. Don't worry. What we can do first is we write everything accordingly. Okay. So I will be calling them like first and second lah, meaning A and B lah. Okay, let's call A and B. A and B for the 2GP. So that we won't get confused lah. Okay. All right. So the key here is we want to find the we need this 4 to the power of n minus 2. We need this to appear when we are comparing the two of them. Okay. All right. So next, we can first write for the nth term. Okay, nth term. So meaning we have T and A equals, and another one T and B equals. Okay. So it is going to be A r to the power of n minus 1, and this one A r to the power of n minus 1. Okay, this is the formula. Okay, so you can see that for the A, our R is going to be 16 over A, which means, okay, for example, if A we use A equals 80, and this one we use A equals 20, our R will be different lah between the two of them. So then we can replace everything. A is 80, and then our R for A is 16 over 80, which is 1 over 5 to the power of n minus 1, like that. And then for T and B, we have 20. And then 16 divided by 20, that is going to be 4 over 5, okay? N minus 1. Okay, now the question is, we want this, okay? Please remember, we want this. This one, okay? So there are several ways where you can prove this, okay? One of them is this. You can see T and A over T and B is what? This is what we can try first. Okay, this is one of the ways. I'm not saying this is the only way. This is one of the ways. We write 80 and then 1 over 5 to the power of n minus 1. Divide 20 and then 4 over 5 to the power of n minus 1. We can try this first. So 80 divided 20 is 40. So we can do that. Oh, wait, sorry. T and A, the small, the A is small, okay? Equals, okay, so now we have 40. Sorry, not 40, 4. Oh my God, why did I write 40? 4, okay. So 4, and then this one, you can see this is 1 over 5 to the power of n, and then 1 over 5 to the power of negative 1 lah, okay? 1 over 5 to the power of negative 1 is just 5. Okay, like that. And then divided by, this one is 4 over 5 to the power of n. And then 4 over 5 to the power of negative 1 is just 5 over 4. Okay, because we can just try like this first. Okay. All right. So now let's do something. 4 times 5. Divide 5 over 4. We get 16. Okay. T and A over T and B equals 16. And then now you can see we have 1 over 5 over 4 over 5. So since they have the same power, we can just divide them straight away. So 1 over 5 divide 4 over 5. We get 1 over 4. So we just write 1 over 4 to the power of n. Like that. Okay. And we are getting closer now. Okay, just look. So T and A over T and B equals. So 16 is 4 squared. We know that. And then 1 over 4 is 4 to the power of negative 1. Okay, to the power of n. So here you can see that when we multiply, we get 4 to the power of 2 minus n, which is what we need. But they want n minus 2. Don't worry, no problem. Okay. You can see that this is T and A over T and B. So if you need the one that they have shown, which is 4 to the power of n minus 2, you just turn upside down. Okay, T and B over T and A. That is going to be 1 over 4 to the power of 2 minus n, which is eventually 4 to the power of n minus 2. Okay. That's why I said this is just one of the ways you can use to prove it. Okay. 4 to the power of n minus 2. And then you can shift the T and A to the right side. Okay. If you want to show the multiplication, right? So you shift this to the right hand side. So 4 to the power of n minus 2 of T and A. Done. Okay. So this is what we need to prove. That we need to get 4 to the power of n minus 2. Okay. So what you can do is you can start by dividing T and A with T and B, or you can also do T and B over T and A. We won't know until we do it. Okay. So since I chose T and A over T and B, okay, and I get 4 to the power of 2 minus n, I have to do 1 over lah, so that it becomes what we need. All right. Okay. So that's all for this question. Okay. All right. Let's go to one more pure maths 1 question, I think, before we go to S1. Okay. Okay. Okay, all right. This is an interesting question. Okay. I think we can try this one. Yeah. But I think this is the same from the same paper. Okay, I want to try finding from a different paper. Okay, because if not, it will be looking like we are solving just one paper, right? Okay. Okay. All right. I think we can try this one. Okay. We can try this one before we move on to stats one. Okay. So the question paper is from October, November 22, paper 13, question number 10. Okay. All right. So you can see a diagram there. Okay. So I think I'll be sketching my own diagram. Okay. Okay. So I hope it is accurate enough lah. But we just need the visualization. Okay. And then we have a line like this. Okay. And then this is 2x minus 1. This is point A. And then we have dot, 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 dot. This is point D. And then this is the shaded part. This is right angle. This is B. Okay. This is Y. This is X. Okay. So then they give us the equation of the circle, which is this. Okay. So from the equation of the circle, we can see where is the center and the radius. Okay. What is the radius? All right. So then they ask us to find the coordinates of A. So finding the coordinates of A will be straightforward. Okay. You can see that coordinates of A is just the intersection between the line and also the circle. So to find the coordinates of point A, we just need to put the equation of the line into the circle. So we can write x squared plus bracket 2x minus 1 close bracket squared equals 2. Just like that. Okay. Because intersection means you have to equate both equations. So x squared plus 4x squared minus 4x plus 1. Okay, this is the expansion. 4x squared minus 4x plus 1 equals 2. Shift everything to the left. So 5x squared and then minus 4x minus 1. Okay. So we can see that 5x and x, 1 and 1. To get negative 4, this is minus, this is plus. Okay. So we get x equals negative 1 over 5 as well as x equals 1. So you can see that A is in the positive side. So definitely this is the one. Okay. This is the x of A. Okay. So then we need the y coordinate. So when x equals 1, we can write y of A equals 2 times 1 minus 1, which is just 1. So final answer for the coordinates of A is 1, 1. That's all. Okay. That's all for the first part. Okay. Next, they ask for the volume. Okay. This is interesting because they want the answer in a specific form. Okay. You can see the answer that they want. So, we can say it is specific and also exact. Okay. From what I can see. So it is rotated about the x-axis. Okay, so the shaded part about the x-axis. Okay, so what we need to do now is to first identify the formula that we need to use. Okay, so we can write volume equals pi integration of something. So when they say rotated about the x-axis, we are going to be writing y squared dx. Okay, I repeat, we need to write pi integration y squared dx. Okay, if they say rotated about the y-axis, then you are going to be using pi integration of x squared dy. All right. Okay. So now we need to find our limits. Okay, and you can see that the shaded part that we are going to be revolving is from point A, which is also point D, and the x coordinate of D is also 1. Okay, so from 1 until the radius. Okay, so you can see x squared plus y squared equals 2, which means x squared plus y squared equals square root 2 squared, which means the radius, okay, or the end point here is square root 2. So 1 until square root 2. This is how you get the limits, okay? All right, so now y squared. So the area that we are looking for is not under the line, but it is under the circle. Yeah, we can see under the curve, okay, or we can see now under the circle. So since we want y squared, then we can rearrange so that the equation of the circle becomes y squared equals 2 minus x squared. Like that. Okay. So we can replace y squared with 2 minus x squared and then dx. So this is what we are going to be finding lah, okay, to get the volume of the shaded part. So now we can write pi integration. So the integration of 2 minus x squared is going to be 2x minus x cubed over 3. Okay, 1 until square root 2. Okay, so far everything is still okay, still fine, right? But later the problem will be to prove the answer in the form that they want. Okay, so we can see that pi, and then when we substitute square root 2, we will get 2 square root 2 minus, this one, square root 2 cube. Okay, I prefer writing it like this first. Okay, you will see why later. And then minus, open bracket, 2 times 1 is 2 minus 1 over 3. Okay, done. So we can see that for the first part here, we have 2 square root 2 minus, okay, so square root 2 cube is going to be, okay, 2 square root 2, okay, over 3. And then minus 2 minus 1 over 3, this is 6 over 3 minus 5 over 3. Okay, done. So 2 square root 2 minus, okay, 2 over 3, because you can see square root 2, they are like terms. So 2 minus 2 over 3, that is going to be 4 over 3. 4 over 3 square root 2 minus 5 over 3. Okay. So now let's find out the way to get the answer in the form that they want. Okay, so they said pi over a. So you can see that the over a comes from the denominator of the 4 over 3 and 5 over 3 lah. So you can take out the 3, so pi over 3, and then b square root c. The b is for square root c, which means square root 2 minus 5. Okay, we already have the answer in the form that they want. Okay, just to be sure whether our answer here is correct or not, let's find out what is the value of our volume here. Pi over 3, and then open bracket 4 square root 2 minus 5. Okay, you can check your answer. Okay, this one is 6879. Okay, so that's right, 6879. So now, how to check the answer? We can use the integration function in our calculator. So 2 minus x squared. And then we have 1 until square root 2. And then don't forget to put pi in front. Okay, or we can just find this first, multiply with pi, the same thing. You can see 6879. Okay, that's how you verify your answer in the exam. Okay, the exam is over. What's the prep for? Okay, it's for anyone who is going to be taking AS level next maybe next session. Okay, isn't the exam, wait, let me check. Isn't the exam, wait, 15th of October. Is it the exam 15th of October 2024? Okay, that's what the preparation is for. Okay. Okay, anyway, the next question is going to be part C. Okay, so they ask, find an exact expression for the perimeter of the shaded region. Okay, perimeter. You can see that the shaded part, okay, we have, okay, so let's define first the perimeter. So you can see the perimeter is going to be what? Okay, so first we can do something like this. Can you see that? Okay, we can do something like this. So why are we doing this? It's because you can see that the area that we need, okay, the shaded part, is going to be the area of this, what do we call this? Sector, okay? And then minus the right angle triangle, and then, okay, wait. Oh, wait. I think my diagram is a bit different than the, wait, let me check. Is there any discrepancy? Wait, perimeter lah, not area. Oh my god, what am I talking about? Sorry. Perimeter, not area. Okay. So the perimeter is going to be length AD, and then plus, okay, let's call this point to be C lah, okay, DC. DC, and then plus the arc length. Okay, the reason why I'm showing you the this one just now, okay, is because if we want to get the arc length, then we have to find it from here, okay, from the origin, and then OAC there. That's the arc length, okay? All right. So then what we can do is we know that AD, okay, we can find first later. So DC is just square root 2 minus 1, okay? Because you know that the coordinate of D is 1, the x coordinate I mean, and then the C there from origin to C is square root 2 because the radius. So length of DC is going to be square root 2 minus 1. Okay. So we can write first square root 2 minus 1. Okay. AD we can find later. So arc AC we can find as well. No problem. Okay. So first we need to find the arc length. We need to, okay, wait. Wait. AD is equal to the x-axis. Perimeter of the shaded region. Okay, it's just 2 marks, okay? I need to think like a 2-mark question. Okay. AC. Okay, wait. This one is 0, this one. Okay, wait. A 2-mark way. Wait. I don't want to do complicated things, so that's why I'm thinking a simpler way. Coordinates of A. Okay. Exact expression for the perimeter of the shaded region. Okay, we have DC. AD is just, oh wait, sorry. AD is just 1 lah. Oh my god, we already have that from the previous part. Okay, now it's just about arc AC lah. Okay. Okay, what we understand right now is, okay, this angle, okay, let's call this theta. OD, we know the length is 1. AD, the length is 1. So then theta should be what? Tan inverse of 1 over 1. So that is going to be pi over 4. Okay. So then we know that the radius is square root 2. Okay. Because radius times angle is the length of arc. So we can write r, which is square root 2. And then theta is pi over 4. Okay. Okay. So you can see that now we have the answer in the exact form. So 1 plus square root 2 minus 1 is 0 lah. Okay. 1 minus 1 is 0. So we have square root 2 plus this is pi square root 2 over 4 lah. Okay. So if you want to simplify the answer more, you can just write like this. Square root 2 bracket 1 plus pi over 4. Okay. Yeah, I think this is the simplest way lah, okay? cm. Don't forget the cm, by the way. Wait, this one cm or not? Okay, okay. No. Unit, okay, or whatever lah, okay? All right. So wait, let me check the answer first, just to make sure I don't mess up. 1, okay, pi over 3, 4 square root 2 minus 5. Square root 2 plus their arc length. Oh, just like that, okay? So square root 2 is what we get just now. And then arc length is pi square root 2 over 4. Yeah, okay? So you can just give the answer in any way that you want, okay? The factorized form or not, whatever, as long as you get the correct arc length and also the square root 2 lah. Okay? All right. Oh, yeah. No worries, okay? Because right now I'm preparing students for the upcoming Geomax 1 exam on the 15th and also another paper which is Stats 1. Okay. All right. So I think now we are going to Stats 1. Okay. All right. Hey, wait. I just realized I need to bring this over. Okay. All right. So now I'm going for statistics 1. Okay. So let's start now. Okay, let me choose a question first. Yep. Okay, I think this question is going to be good. Okay. All right, so let's start by looking at summer 2023 paper 52. Okay. Question number 5. Okay. So maybe some of you a bit struggling with normal distribution. Okay, so now we can first look at normal distribution for our first statistics 1 question. Okay, so for this question, we first write down the normal distribution given. Okay, so we can write X to be normally distributed, and then the mean we write. Okay, listen, for normal distribution, inside the bracket you need to write the mean and the variance. So if they give you the standard deviation, you just write the standard deviation value, but please square it. Okay, if they give you the variance, don't square it anymore lah. Meaning, for example, if the variance is 2, you just write 2 inside. If the variance is 5, just write 5 inside. But let's say the standard deviation, they give standard deviation 2, you have to write 2 squared. Okay, be careful because some students, okay, they forgot to consider this and they got the wrong answer just because they forgot to consider whether what is given is variance or standard deviation. Okay, right. And then length between 15.4 and 16.8 centimeters. So what we need to do here is probability of X between 15.4 and 16.8. Okay. So if you sketch this, okay, you can see that our mean is in the middle, 16.5. 16.8 is quite close to the middle line, and 15.4 a bit far lah, okay? So you can see that the 15.4 will give you a negative Z, and the 16.8 is going to be a positive Z. So what we want is in the middle between the two of them. Okay, so now you have two options. Whether you change both of them into Z first, or you change first, for example, you can see that the area that we want is probability of X less than 16.8 minus probability of X less than 15.4. You can also do like this, meaning some of you prefer changing it to Z first, but I prefer writing it in the way that we need. You can do like this, for example, less than 16.8 minus less than 15.4, or you can also do 1 minus more than 16.8 minus less than 15.4, up to you. Okay, there are a lot of ways for you to do this one. Okay, all right. So now we can use the formula for the Z, okay, meaning probability of Z less than 16.8 minus 16.5 divided by 0.6, okay, because we are going to be dividing by the standard deviation. Okay, and this one, Z less than 15.4 minus 16.5 divided by 0.6. Okay, so then remember your Z value must be correct to 3 decimal places. Okay, So we can write 16.8 minus 16.5 divided by 0.6. So we get 0.5 minus z less than 15.4 minus 16.5 divided by 0.6. Okay, so this is negative 1.833 lah. Okay, so remember, if you want to use the normal distribution table, two important requirements. First, z value must be positive. Second, the arrow must be a less than arrow. Okay, so you can see that for the z less than 0.5, conditions are met. You can use the table straight away. However, for the z less than negative 1.833, the z is negative. So you have to change this first. Okay, so for z 0.5, okay, let's go down. Okay, you can see that for 0.5, the probability is 6915. Okay, 0.6915 minus, okay, so to modify this, you can see from your table, okay, you can see that they given us this. If your z value is negative, you just do 1 minus. Okay, so we can write 1 minus probability of z less than 1.833. Okay, everything already given in the table. Okay, don't worry. So minus 1 minus what? 1.833. So 1.8, you can see 1.83 over here. 1.833 is 2. You add 2. So 9666. Not a lot of 6 there. 0.9666. Meaning, when they say add here, you have to add only the last 2 digits, okay? Which means here, 1.833, you are adding 2 to the last 2 digits, which means 64 plus 2. So 9666. Okay, and then just calculate. So 1 minus 0.9666 and then 0.6915 minus answer. So the answer, okay, remember, don't give the answer correct to 3 significant figures yet, because that is not the final answer, because they want us to find how many of the, 180, right? 150. How many of the 150 birds? So for this one, you just write the full probability. Okay, 6581. And then next, what do? The 150, you multiply with 0.6581. Okay, so the answer is, of course, it's going to be a decimal, but please don't write the decimal answer, because the number of birds cannot be a decimal. So first you write 98.715, and then you can write either 98 or 99, okay? Don't write any other values other than this, okay? I know that most of you are going to see, oh, 98.715, okay, so we round up, okay? No problem. As long as you give an integer, okay, because number of birds. If you give 98.715, the problem is it is going to be wrong, okay? 98 or 99, okay? You can check the mark scheme whether they accept 98 or not, but 99, I'm sure they accept, okay? So that's all for part E. Okay, part B. Okay, so maybe most of you know how to do question part A, okay, because it is quite straightforward. Okay, they just ask the probability for between two values, okay? But if they give us probability like 72% of eastern bluebirds, length greater than 70.1. Okay, so for this one, okay, some of you may be a bit blur on how to do it. Okay, no problem. So they said eastern bluebirds, meaning this is another type. Okay, so let's call this to be Y. Okay, normal distribution and then 18.4, but they give the standard deviation sigma. So here you write sigma squared. Okay, like what I said, variance is the one written in the bracket. Okay, so they said 72%. So you write first, Y greater than 17.1 is 0.72. Okay, so there are several ways that you can do this one, but what I personally prefer, okay, again, we sketch a bell-shaped graph. So we know the arrow that we use here is more than. So usually what I taught my students, okay, if the arrow is more than, you start from the right side, okay? And if the probability from the right side exceeds 0.5, that means you are going to cross over the middle line. So when it crosses over the middle line, meaning that you are going to end up in the negative side. Okay, so in this case, you can see that we have 0.72, meaning that we are going to cross the middle line, which means we will have something like this, for example. Okay, which means our Z value is going to be negative. So we can write here, Z is negative something. Okay, we can write Z negative lah. Okay, Z negative. Okay, after that, after we know that our Z is going to be negative, then we need to find the Z value. So you remember that Z value, probability must be bigger than 0.5, because if you look at the table, the smallest probability is 0.5. So since our probability here is already more than 0.5, then we can straight away find from the table. Okay, so 0.72, okay, remember you have to go and find the one closest to 0.72 and a bit less. So you can see here we have 7190 and 7224. So 7190 is the one less than 72. Okay, so to get 72, the 90 we must add with 10. Okay, because like I said, the add here we are adding the number into the last two digits. So if we add 90 with 10, we get 100, which means we are going to have 0.72. So now our Z value is 0.583. But we have to write the negative lah. Like I said, negative 0.583. So after that, we are just going to use the formula. Okay. So we write Z equals Y minus mean divided by standard deviation. So Z is negative 0.583 equals our Y is 17.1 minus 18.4 divided by standard deviation. So now our standard deviation is, okay, we can just calculate straight away. 17.1 minus 18.4 and then divided by negative 0.583. So we get our answer to be 2.23. Okay, for the final answer for the standard deviation. Okay. All right, that's all for part B. And the next one is part C. So part C, they asked to use approximation. Okay, and we have to use the Eastern Bluebirds, meaning we are going to be using from part B lah. Because from part A just now, they said about Western Bluebirds. Okay, so Eastern Bluebirds for part C. So remember, for approximation, you have to justify the approximation first. Okay, some of you may say no need because they said already use approximation, and the only approximation that we have in S1 is binomial to normal. Okay, I know, but I like to justify. It won't take long. Okay, 18.4 and then standard deviation is 2.23, so we can square this. It becomes 4.972 lah. Let's just write 4.972. Okay, so now they said use approximation. So what we are going to do? Oh, wait. Oh, I forgot. Okay, this is originally binomial. Oh my god. Luckily, I realized. Okay, binomially distributed. And then they said fewer than 80 of these 120 birds have length greater than 17.1. Okay, no problem. Okay, they said 80 of this 120. So we have n to be 120. So binomial, we have to write n and p. So the probability length greater than 17.1. So greater than 17.1 meaning the probability that we already given in part B. Greater than 17.1 is 0.72. So we can straight away write our p to be 0.72. Okay. And then to justify whether we can use normal approximation or not, we have to write NP and NQ. We have to find what are the values. Okay. 120 times 0.28. Okay. If both of them are greater than 5, then we can use normal approximation. So 86.4 and then 120 times 0.28 as well as 33.6. So yes, both have been justified to be greater than 5. So use normal approximation. Okay. Because sometimes they ask question where we need to justify why we can use the normal approximation. So that's why I always can justify. So then for the mean, it's just NP. So mean is 86.4. And then the variance is NPQ, which means 86.4 times 0.28. So this is 24.192. Okay. Then we can write again y is normally distributed with the mean 86.4 and variance 24.192. Okay. So far up to this point, okay, like everything is quite straightforward, still straightforward, it's still okay, right? Remember, there's one more problem that sometimes students overlook. It's not that students don't know, but they overlook at this one thing. When we are dealing with binomial to normal approximation, okay? Oh yeah, by the way, what we want right now, fewer than 80 of this 120. So we can write y less than, okay, 80. Right. So the problem with binomial to normal approximation, most students will kind of overlook at continuity correction. Okay, because yeah, we know that okay, we have 80, so we like, oh, 80 minus 86.4, but remember, binomial to normal, we have to apply continuity correction. So for continuity correction, we have to first get the correct arrow. So when they say fewer than, it's just less than. Because less than and less than equals to, there will be difference for the continuity correction. Okay. So for less than 80, we don't want 80. So if we take 80.5, it will include 80. So that's why we are going to be taking 79.5 instead. Okay. Minus 86.4 divide square root of 24.192. Okay. So probability of Z less than. So let's calculate 79.5 minus 86.4. Okay, wait. Okay. Divided by square root of 24.192. Okay, remember 3 decimal places, negative 1.403. Okay, and remember when we have less than and then negative, it's just 1 minus. So now we can find Z less than 1.403. 1.40 is over here. 3 is just, oh wait, 140. 3 is over here. 4. So 9196. 9196. So 1 minus this, what do we get? 1 minus 0.9196, we get 0.0804 for the final answer. Okay, so before that, let's check the answer first. Expected number must be 98 or 99. Yes, they said already. It must be 98 or 99 only, not any other than these two. And then for part B, they said 2.23, correct? And then 0.0804, correct? Okay, so done. Sir, can you explain the last part of part B, please? Okay, so last part. Okay, so let me just repeat what happened in part B. Okay, so what happened in part B? We are finding the Z value. Okay, we are finding the Z value for the given probability and length. Okay, so they said if they say greater than 17.1 is equal to 0.72. So when the arrow is greater, we are going to start from the right side. Start meaning we take probability or we take the area from the right side. Okay, if they say the arrow is less than, okay, or less than equals to, doesn't matter, then we are going to be taking the area from the left side. Okay, so if the area from the right side is more than 0.5, because you know that this is the middle line. So when this is the middle line, it divides the area into 0.5, 0.5, because you know total probability is 1. So the area is 1. Okay. So the line here is the symmetrical line. So anything to the right, the total is 0.5. To the left is also 0.5. So when the probability from the right is more than 0.5, then it's going to exceed the middle line. So it is going to be going over to the left side. Okay, and that's why we know that our Z here is negative, because you know that this is 0, right? Okay, for Z, this is 0. So anything to the right is positive Z, anything to the left is negative Z. So that's how we know that our Z is negative. Okay, that meaning for you to find the Z value, you just have to determine positive or negative. And then next, you just have to find the Z value from the table. So to find the Z value, if the probability is already more than 0.5, you can straight away find from the table. If the probability is less than 0.5, you can do 1 minus the probability. Let's say, for example, if the probability that they give is 0.2, so you do 1 minus 0.2, you will get 0.8. So you use the 0.8 to look the Z value from the table, like that. And then after you get the negative 0.583, okay, you can use inside the formula, Z equals X minus mean divided standard deviation, or this one is Y, because I declare it as Y, okay, it's the same thing. So then you just plug in everything and then you will get the answer. Okay. Right. I hope that helps. Okay. All right. So now we can move on to the next question. Okay, I won't be doing normal distribution anymore, okay, because I will be doing like some other topic. Okay. All right. Yes, okay, we can try this one. Okay, the next paper is okay. The same year, the same session, but different variant. Variant 51, question 6. Okay, let's look at this one. All right, for this one is about probability distribution table. Okay, so we have four-sided dice. Oh my god, four-sided dice. Okay, you have to say it properly. Labeled 1, 2, 3, 4. Okay, so the random variable x denotes the number of 2's obtained. Okay, so for this question, you have 4 dice. Okay, four-sided dice. Okay, so when you want to get the number of 2's obtained, okay, you have to do it carefully. Okay, let me show you how. Okay. Probability of x equals 3 is like this. You are getting the number 2 3 times, or from the 3 dice. Okay, so this is what you can do. You can first find the possible outcomes. Possible outcome, which means we can have 2, 2, 2, not 2. You can see, plus 2, 2, not 2, 2, plus probability of 2, not 2, 2, 2, plus probability of not 2, 2, 2, 2. Okay, you must be wondering, okay, what is this actually? Okay, it's like this. We are getting the number 2, 3. 3 of the 4 dice, we get the number 2. The problem is which dice that we don't get the number 2. So this one, we are considering which dice that we don't get the number 2 lah. Okay, so the probability to get the number 2, okay, because you can see that for 1 dice, to get the number 2 is 1 over 4, right? So to not, so if we don't get the number 2 is 1 over 4, sorry, 3 over 4, okay? So we can write like this. Okay. You can see that the probability for all of them will be the same because they are all the same case, just different outcome. So we can write 4 times 1 over 4 to the power of 3 and then 3 over 4 to the power of 1. Okay, let me repeat, okay, so that you are not confused. So what we are doing right now is we are considering out of the 4 dice, which dice that we don't get the 2. Like for this one, the 4th dice doesn't get the 2. For this one, the 3rd dice doesn't get the 2. For this case, the 2nd dice doesn't get the 2. And the last one, the 1st dice doesn't get the 2. So we have to consider like this. Okay? So that's why we have to multiply by 4. And why 1 over 4 to the power of 3? Because we are getting the 2 out of the 3 dice. Okay? So the probability of getting a number 2 on the dice is 1 over 4. And we have it 3 times. So that's why 1 over 4 to the power of 3. And the probability to get not 2 is 3 over 4. That's why we have power of 1. So now when you calculate this, you will get 3 over 64. You can see this. 1 over 4 to the power of 3 times 3 over 4. You can see we get 3 over 64. That's it. Okay. So that's the explanation for part A. Okay. For part B, we have to complete the table. Okay, so let's sketch the table over here. So you can see we have 0 until 4. So we only have to complete for 1 and 2. Okay. So there's one thing that I would like to remind everyone, okay, who is watching right now. Please don't do this. Okay, what do I mean? Let's say x equals 1, you get a probability. And what's left is x equals 2. If possible, don't do 1 minus everything else. Because if your x equals 1 is wrong, then your x equals 2 is going to be wrong as well. So it's better for you to find individually without using the complementary method. Okay? Even though sometimes you are going to get away with it, but if you are wrong, then you will know. If you do it individually, like that. Okay? 81 over 256. Okay, and then we have 1, 2, 3, and then 4. Okay. So to get 1 and 2 is the same idea on how we get the x equals 3 just now. Okay. Let me show you. So probability of x equals 1, like I said, this time the number 2 only appears on one of the dice. Okay. So you will have the same thing here, but imagine the 2 apostrophe, or we can say the 2 prime, is the 2 right now. And the other 2's are the 2 primes. Okay. So you will have again 4 cases, but this time the 1 over 4, the 2 only appear once, so that's why times to the power of 1. And not 2, we have 3 of them. So that's why power of 3. Okay. I hope I'm not going too fast. Okay. All right. So you have 4 cases. Okay, and then the 2 only appear once, and the not 2 appears 3 times. Okay, out of the 3 dice. So 3 over 4. So then for x equals 1, we will get, okay, we change that. We change this one, 3 over 4. We change this 1 over 4. So we get 27 over 64. Okay. So I know that some of you will be doing like, okay, we have everything, so 1 minus everything. Okay, you can do that. But if your x equals 1 is wrong, then it will be wrong. That's why I don't recommend that. Okay, so for x equals 2, what you are going to do is, okay, you will have to consider how many cases that you have. Okay, you can use the same idea. Okay, like which dice that gets the 2, which dice doesn't get the 2. All right. So the simplest way, okay, the simplest way for you to get around this thing, okay, we can see here. Okay, just now, we have one of the dice to be having 2, the other 3 dice will not having 2. So if we have 2 of the dice to be 2 and the other 2 dice is not 2, you can get it as simple as this, 4C2. Okay, meaning there are 6 cases. Meaning for the previous case, x equals 1 or x equals 3, you only have 4C1 or 4C3. Now you have 4C2. Okay. And then this is 1 over 4 to the power of 2, and then 3 over 4 to the power of 2. Okay. Meaning 4C2 here, meaning we have 6 possible cases. Okay, like what we have discussed. So now 1 over 4 squared times 3 over 4 squared. So we get 27 over 128. Okay, so now, moment of truth, we have to check whether all of them add up to 1. Okay, the probabilities. So plus 27 over 64. If it doesn't add up to 1, that means what you found, wrong. Okay, maybe both of them wrong, maybe one of them wrong. Okay, you have to check. Plus 1 over 256. And as you can see, they add up to 1. So we can say that it's correct. Okay. So that's all for part B. Okay, expectation of x. So for expectation of x, it is just straightforward application of multiplying top and bottom, meaning x with the probability. So 0, we don't have to consider. So we can start with 1 times 27 over 64, right? And then plus 2 times 27 over 128, plus 3 times 3 over 64, okay, plus 4 times 1 over 256, okay? This is just simple lah. Don't have to worry too much. So 27 over 64, but we can speed calculate this thing lah, okay? 27 times 2 is 58 over 128, plus 9 over 64, plus 4 over 256. So we get the expectation to be 1. Okay, done. So the last one is part D. Okay, so part D, 5 marks. Okay, so maybe this one is going to be the difficult one. Let's see. So the 4 dice thrown 96 occasions. I was like, oh wow, okay, 96 occasions. So this is an indication of what we have right now is a binomial. Okay, so let's write this thing. Let's write y to be binomially distributed. So our n is 96. Okay, and then they said he obtains at least 2 2s. Oh my god. 2 2s. Okay, so this is the problem, okay, that some of you might have. How do we understand at least 2 2s? Okay, this is the thing. To get at least 2 2s, meaning we can get 2 2s, 3 2s, or 4 2s. Okay, so the probability for this binomial we can add. So you can write x greater than or equals to 2 to be equal to 27 over 128 plus 3 over 64 plus 1 over 256. Okay, this is the P that we are going to be using for our binomial. Okay, 27 over 128 plus 3 over 64 and finally plus 1 over 256. So we get 67 over 256. This is the probability. Okay, so 67 over 256. Okay, so then they say approximation. So again, this is going to be binomial to normal approximation. So as I said before, we have to find our NP and NQ first. Okay, so 96 times 67 over 256. 96 times 1 minus 67 over 256. Okay, 189 over 256. And I said already, if they both greater than 5, then we can use normal approximation to this binomial. Greater than 5. Okay, so if the question doesn't ask you for the justification, is it okay? Yeah, it is okay. Okay, but I will still write it anyway, okay? Because just to show that we can use the normal approximation. Use normal approximation. So then our mean is NP, which is 25.125. Our variance is NPQ, 25.125 times 189 over 256. So this is, oh wait, okay, 18.549. Okay, don't take too long, don't take too short. Okay, done. So then we can move on over here. So we can write our y as normal distribution. Y normally distributed. And then we have 25.125 and then our variance 18.549. So now what they want, fewer than 20. Okay, please be careful with the arrow. Fewer than 20 meaning less than 20. So don't forget to apply the continuity correction. So the continuity correction that we are going to be applying is 19.5 because 20.5 will include 20. So we don't want to include 20, so we need to take 19.5, okay? Minus 25.125 divide by, remember this is variance, so square root 18.549. Okay, definitely this z will be negative, okay, as you can see. So square root of this and then 19.5 minus 25.125. Divide answer, we get negative 1.306. 3 decimal places for the z, okay? So then this is going to be 1 minus probability of z less than 1.306. So we can first find what's the probability of 1.306. So 1.30 is over here. So 6, we need to add 10. So the 32, okay, like I said, the last 2 digits, we need to add 10. Okay, so 9042. 1 minus 0.9042. So finally, the answer, 1 minus 0.9042, we get 0.0958 for the final answer. Okay, all right. So now let's check the answer first before we go to our last question for today. 3 over 64 done. Okay, so 27, 64, 27, 128, correct. Expectation is 1, probability is 0.0958. Okay. So now let's move on to our final question for today. Okay, for our live today. Okay. I think we can first, sorry, not first. I think we can try one permutation combination question for today. Okay. So the paper is summer 2023, paper 52, question number 6. Okay. So let's start. So now for the first question, okay, they give us a group of 25 people, and then there are swimmers, there are cyclists, and there are runners. So they can only compete in one of these sports, okay? So we are going to be taking 7 people from this 25. So they ask, find the number of different ways in which, okay, we have exactly 1 swimmer and these 4 cyclists and most 2 runners. Okay, so for this one, always remember to form a simple like column like this. Swimmer, cyclist, and then runners. Okay. On top, you can write down the total that we have. We have 6 swimmers in total, we have 8 cyclists in total, and we have 11 runners in total. Okay. So they said exactly 1 swimmer, so this one is going to be 1 all the time, the swimmer. So for the cyclist, we have to start with 4. So if we have 1 swimmer, 4 cyclists, that means we can have 2 runners. Because you can see that we add all of them, it must total up to 7. So 1, 4, 2, that is 7. So the next one, swimmer, we can have 1. We can have 5 cyclists and 1 runner. So the meaning of at most 2 runners, meaning you can also have 0 runner, no problem. So 1 swimmer, 6 cyclists, 0 runners. Okay. So these are the 3 cases that we can have. Okay. So now we can find. So the reason why we put the total swimmers, cyclists, and runners on top, because we can easily, meaning you don't have to look at your question paper anymore. 6C1, 8C4, 11C2. Okay. And then 6C1, 8C5, and then 11C1. Finally, 6C1, 8C6, okay, 11C0. 11C0 is just 1. Okay. So now let's calculate. 6C1 is 6, 8C4, and then times 11C2. 23,100. Okay, later on, we are going to add all of them. And that's the answer. And then 11C1, 8C5, 3696. And finally, 11C0, meaning 1, 8C6, 168. Okay, so we add all of them. That's the final answer. 26,964. And that's the final answer. Okay, this is combination because we are selecting, okay, people, meaning no permutation involved. Okay, that's all for part A, and now let's look at part B. Okay, so now this is going to be a permutation question because, stand in a line for a photograph, you can see. So when you are standing in a line for a photograph, that means you are going to be rearranging yourself. Okay. So they said we have 2 swimmers, 3 cyclists, 4 runners. If the swimmers stand together, the cyclists stand together, the runners stand together. Okay, this is very straightforward. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you have to write 9 spaces first. And then you have to give, like for the 2 swimmers, they are going to be together. So you put a box, okay, for the 2 swimmers. And then for the 3 cyclists, you put 3 spaces for the 3 cyclists. And then for the 4 runners, you put a box for the 4 runners, okay? So once you have all of them like to be together in their own group, we are left with 3 spaces, meaning the group of swimmers, the group of cyclists, and the group of runners. So to rearrange this, for the swimmers, you have 2 factorials, meaning between the 2 of them, they can rearrange themselves. For the cyclists, they can rearrange themselves, so 3 factorials. The runners, we have 4 factorials. And don't forget, between the groups also, we can rearrange. So 3 factorials from the rearrangement of the 3 groups. So then, this is the final answer. 2 times 6 times 24 times 6. 1,728. That's the final answer for part. Okay, is C the last part? Yeah, C is the last part. So how many different arrangements are there? None of the cyclists stand next to each other. Okay, this question is quite normal if you look at the past paper. So when they say none of the cyclists stand next to each other, you also start with 9 spaces, of course. Okay, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so when none of the cyclists stand next to each other, so we are going to be considering where we can put the cyclists if, okay, they cannot be next to each other. So we have 3 cyclists. So the first cyclist can be here. First cyclist. Okay. The next cyclist can be in the third space so that they are not next to each other. And the third and last cyclist can be over here, 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 and here. Okay. This is the trick. Meaning, okay, we don't have like 1, 2, 3, 4, 5, 6, 7. We don't have 7 cyclists. We have 3 cyclists. But the last cyclist, that cyclist can be anywhere in these spaces. Okay. So now what we can do is 1, 2, 3, 4, 5, 6, 7. 7 possible spaces that we can rearrange the 3 cyclists. So that's how we get the 7p3. Okay. So 7p3 times. So now we already rearranged the cyclists. So we have another 2 swimmers and 4 runners. So 2 factorials times 4 factorials. Okay. Because the swimmers and runners, there's no restriction for them. The restriction only for the cyclists. Okay. So let's find the answer. 7p3 times 2 factorial is 2, 4 factorial is 24, 10,080. Okay. All right. Let's check the answer first, okay? Because permutation combination, if you mess up even one thing, then it's going to be wrong lah, okay? All right, 26,964, correct. 1728, correct. 151200, okay, yeah, it's wrong. So I messed up something. Let me check. Okay. Wait, how many different ways are there of the 9 people if none of the cyclists stand next to each other? Okay, we have 3 cyclists. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay. And then 2 factorials. And then 4 factorials. Wait. 7p3 to 24. Okay, wait. Okay, no problem. Okay, what went wrong? Let me check. Okay. None of the cyclists stand next to each other. Okay. 1, 2, 3, 4, 5, 6, 7. Oh, wait. Oh my God. Oh my God. I just realized. Sorry. I just realized. Cyclists and runners. Swimmers and runners. Why do we need to consider 2 factorial, 4 factorial? It's just 6 factorials. Okay, because there's no restriction for them. Oh my God. I just realized that. I don't know why I separate the 2 factorials and the 4 factorials. Okay, because after we rearrange the 3 cyclists, we have 4 swimmers, 4 runners and 2 swimmers. So we can rearrange the 6 of them, okay, however that we want. So that is 6 factorials, okay? I don't know why just now I separate the 2 and the 4, okay? All right, so yeah, if we do like this, then we will get the answer. 6 factorials. You see? 151,200. Okay. All right. Okay, so if you look at the answer, they will say something like 6 factorials times 7 times 6 times 5, okay? This one, up to you, okay? Because I'm more comfortable with the 7p3 times 6 factorials, okay? Because this method is what I understand better lah, okay? Let me repeat how we get this, okay? The first cyclist we can put in the first space, the second cyclist we can put in the third space, okay? And the last cyclist we can put anywhere from the 5th space onwards, okay? So we have 3 cyclists and we have 1, 2, 3, 4, 5, 6, 7. 7 available spaces for the 3 cyclists. That's how we get the 7p3, okay? And finally, the 6 factorials is for the remaining 2 swimmers and 4 runners. We can rearrange however that we want. That's why 6 factorials, okay? All right. Okay. So I think that's all the time that we have for today. Yeah. Okay. If I have time, maybe I will do maybe another live session maybe tomorrow. Okay. Just wait for the update in our YouTube channel. Okay. If I I'm going to have another live session for tomorrow. Okay, because the exam is next week. So I hope I can help however that I can lah for the remaining time that we have. All right. So thank you everyone for watching this live. Okay, so if there's any like comment or whatever, you can comment in the community section. Okay. All right. So that's all for today. Thank you very much. Okay. I'll see you again.